In this third video on operators, we're going to show that the operator psi sub m of theta, which is 2 pi the minus 1/2 e to the I m theta, is orthonormal over the interval 0 pi. When we show an operator is orthonormal over a certain interval, we show that the integral over that interval of the operator sub m times the operator sub n both multiplied together, in this case d theta, is equal to either 1 when the subscripts m and n are equal, or 0 if the subscripts m and n are not equal. So orthonormal, which also means orthogonal, another way of saying orthogonal, or perpendicular in a more abstract setting, it's 1 if they're the same operator, essentially, that you're multiplying together, and when you're multiplying the different operators together, the product then integrated is 0. So let's see how we show that on the next blackboard, but let's first take a closer look at what we mean by e to the I theta. E to the I theta is defined by de Moivre's theorem to be cosine theta plus I sine theta. We'll show, I think you saw a proof of that at one point. I'll show it quickly on the next blackboard. Also, if we had e to the minus I theta, that would be cosine minus theta, which is cosine theta, plus I sine minus theta. Sine of minus theta is minus sine theta. So e to the minus I theta is cosine theta minus I sine theta. So let's show where this formula comes from first before we pick up the orthogonality part of this. Okay, so recall the Maclaurin expansion for the function e to the x, 1 plus x squared over 2 factorial, x cubed over 3 factorial, x to the fourth over 4 factorial, etc. The powers of I, so I is I squared is minus 1, I cubed is minus I to the fourth is 1, and then I and I to the fifth are I squared and I to the sixth are minus 1, etc. So when we take the expansion of e to the I theta, we get, substituting in I theta for x, 1 plus I theta plus I theta squared over 2 factorial, I theta cubed over 3 factorial, etc. And now we're going to separate it out into the part that does not have an I in it and the part that does have an I in it. So these even powered terms, because I squared is minus 1, does not have an I in it, has a minus 1 in it. I to the fourth is 1, so it doesn't have an I in it. And then the odd powered terms all have an I theta. I cubed is minus I, and I to the fifth is I, so we factor the I out, and we have theta minus theta cubed over 3 factorial plus theta fifth over 5 factorial. So if we also expand cosine theta, which is an even series, we get 1 minus theta squared over 2 factorial plus theta to the fourth over 4 factorial minus theta 6 over 6 factorial, continuing, plus theta to the 8th over 8 factorial, etc. And sine theta, the odd series, has theta minus theta cubed over 3 factorial plus theta to the fifth over 5 factorial, etc. So you can see that if we combine these two, we combine cosine theta and I sine theta, that is, we multiply everything down here on the sine theta term by I, that we have exactly the same thing as we got from e to the I theta, which was here. So again, e to the I theta here and cosine theta plus I sine theta here are both the same thing. So that shows this identity here that we're going to use in showing the orthogonality. So we're trying to show that psi sub m times psi sub n, when we integrate from 0 to 2 pi, is either 1 or 0. So let's set that up on the next blackboard. Excuse me, I made a mistake on the orthonormal condition we're trying to show. There should be an asterisk here, and remember that asterisk means complex conjugate. So when we take complex conjugate, we're going to get a negative sign on the I part of the expression. Okay, so we've got psi m asterisk times psi n d theta. Psi m asterisk is going to be e to the minus m theta, because when you take the complex conjugate, you make this term negative, and that is this, which is a negative sign here, which means we've got e to the minus I theta. So e to the minus m theta times e to the I n theta. And if we combine those two terms together by adding the exponents, we get this. So we get e to the I n minus m theta. And we're going to split that into its two parts, the cosine part and the sine part, following this identity that we have developed, the de Moivre's identity. So we have just split it up into the cosine part and the I sine part. Now before we go on to the next blackboard, let's note that when we integrate cosine of ax, we get sine of ax over a, and if we integrate sine of ax, we get minus cosine of ax over a. And in our case here, the constant that is multiplying the sine is the a is n minus m, and the constant multiplying the theta over here with the cosine is also n minus m. So let's integrate these, or perform these two integrations on the next blackboard. So we've integrated the cosine, that gave us sine of a theta divided by a, and we've integrated the I sine part of it over here, and that gave us minus cosine. That gave us the minus cosine of a theta, the a being here, divided by a. So let's note that when n is not equal to m, n minus m, which occurs here, 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 and here, is an integer. So this right here, when we plug the 2 pi in, we're taking an integer multiple of 2 pi when we do this, and so that's sine of 2 pi or 4 pi or 6 pi or negative 2 pi, negative 4 pi, negative 6 pi, in which case all of these numerators are 0. And the same is true when we plug in, or the same occurs when we plug in either 2 pi or 0. So everything is 0 in this term here. For this next term over here, the cosine term, when we plug in 2 pi, we have an integral multiple of 2 pi. Recall that cosine of 2 pi is 1, right on the unit circle. Cosine of a multiple of 2 pi is right here, and cosine of 0 is also the same place. The cosine is the x value, so we're getting 1 whether we plug in 2 pi or whether we plug in 0, and so essentially what we're getting for this part is 1 minus 1, and so that is 0. Also, that term is also 0. So now let's see what happens when n equals m. So when n equals m, here and here, we are essentially taking the cosine, the integral of the cosine of 0 and the integral of the sine of 0. So let's pick that up. So the cosine of 0 is equal to 1, so we're integrating d theta, so we get 1 over 2 pi, the integral between 0 and 2 pi of d theta, which is 1 over 2 pi, 1 over 2 pi theta evaluated between 0 and 2 pi, which is 1 over 2 pi times 2 pi minus 0, which is 1. And if we look at the other integral, this integral here, sine of 0 is 0, so we're just taking the integral of 0, and therefore this entire integral, and therefore this entire term is 0, and so the result that we get is 1, and if we look back to what we were trying to show, well, let's summarize this page. So if n did not equal m, notice that we got 0 here and 0 here, so we got 0. And in the case when n did equal m, we got 1 for this first integral, and we got 0 for the second integral. So looking back at what we were trying to show, that when m equals m, we got 1, we did get that, and when m equals m, we should get 0, and that's what we got. So we actually showed that this function right here, this function psi sub m, we showed that it is orthonormal over this interval because we showed 1 when m equaled m and 0 when m did not equal m. So that concludes this video, and it is the last video on operators.